Yeah, good morning, students. In the previous class, we started about discussing on different types of sorting techniques, and one technique, simple sorting, we have discussed regarding this bubble sort technique. So now, in today's classroom discussion topic, we would like to discuss about two more sorting techniques. That is insertion sort as well as the bubble sort, selection sort. So now I would like to share my screen. Hope my screen is visible to you. So this is a classroom discussion topic CDT 32 or week 11 lecture 2 selection sort and insertion sort techniques. So summary of the previous CDT is that we discussed about the sorting techniques like internal sorting, what is meant by internal sorting and what is meant by external sorting, and under that internal sorting we discussed about bubble sort technique. So in this bubble sort technique consecutive adjacent elements are going to be compared, and if they are not in the required order, swapping those two elements. Otherwise we will continue this process. Okay, so internal sorting deals with the sorting of the data which is stored in the computer's memory. So external sorting deals with the data which is stored in the files. So the objective of this today's session is that this session will develop the knowledge on selection sort as well as insertion sort technique. So the outcome of this today's session is that upon completion of this CDT, students are able to implement selection sort technique as well as insertion sort technique, and trying to compare which sorting technique will give better result for a given set of data. So what is meant by a selection sort? Selection sort is a sorting algorithm that selects the smallest element from an unsorted list in each iteration and places that element at the beginning of the unsorted list. So select this is what for example, if you consider this 20, 12, 10, 15, 2, these are the five elements in the given array. Now what we will do here is that select the first element as minimum. So we will select this is the minimum, and we try to find, okay, so compare this minimum element with the second element. If the second element is smaller than this minimum, so we are saying that 20 is the minimum element. Okay, so if the second element is smaller than minimum, assign that second element as a minimum. Okay, so in this case what is happening here, we assumed initially 20 is the minimum, then we are comparing with 12, so now the minimum is equal to 12. So again we are comparing with the next element, so 10, so again the minimum is 10. So 10 again we are comparing with 15, so 15 is not minimum, 10 is the minimum. Then we are going for 2, so 2 is the minimum, so minimum we are assigning 2. So that means the minimum element is 2, so that will be interchanged with okay, so compare the minimum with the remaining elements, so 2 is the minimum element. So with the third element, again third element is smaller, then assign minimum third element, otherwise do nothing, the process goes on until the last element. Fine. So this last element and first element will be swapping. So after each iteration, minimum is placed in the first position in the unsorted list. Fine. So for each iteration, indexing starts from the first unsorted element. So step 1, 2, 3 are repeated until all the elements are placed at their correct position. So step 0, so we are comparing this 20 is the minimum, then 12 and 10 we are comparing with the minimum value is at index 1, minimum value is at index 2, and again here we are comparing minimum value is at index 2 only, here we are comparing minimum value it is index 4. So now we will swap the index first iteration, we will swap this 0th element and then the minimum element found at the index value 4, so that we will interchange that. Then again with step 2 here, so we will take 12 and 10, so minimum is 12 we will assume, so 10 minimum value is found at index 2, and then 15 no it is not minimum, 20 no it is not minimum, then we will swap these two elements, we will swap, that is the element present in the index location 1 and the element found at the minimum element found at the index 2. So this is the second iteration. So this is the third iteration. In the third iteration we will take this a of 2 location element, and we are trying to find a minimum value. So 12, 12 and 15 we will compare with, no, it is 12 only the minimum, 20, no, 20 is the minimum. So minimum found at index 2. So the index 2 and element and the minimum element which we have found again at the same index, so already it is in proper place. So this is what the third iteration is completed. So this is the fourth iteration. Now we will take 15 and minimum we will try to find. So 15 is already in right place, so this is a fourth index. Then here this is the 20 last element. So single element itself is a sorted element. So this is a program for selection sort. So we are reading the elements. This part is same for any sorting technique. And then we are trying to take ith location for I equal 0, I less than n minus 1, I plus plus, because we have n elements, n minus 1 passes are required to sort this. So the outer loop is always same as similar to bubble sort technique. Now here position equal to I. So we are assuming that at ith position the minimum element is found. So from j is equal to I plus 1 to n, we are trying to find the minimum element where we can able to find it. So if position is not equal to I, then we are swapping that elements. Okay. So if position is not equal to I, then we are just swapping AR of I location with AR of position location element. We are swapping it. Fine. So this is what the uh, technique is basically. So this is printing of these elements. Okay. So printing of these elements, we are doing that. So then coming to the insertion sort works similar to the sorting of the deck of cards in hands. So it is assumed that the first card is already sorted in the card game, and then we select an unsorted card. If the selected unsorted card is greater than the first card, it will be placed at the right side, otherwise it will be placed at the left side. So similarly, all unsorted cards are taken and put in their exact place. So the idea behind the insertion sort is that first take an element, iterate it through the sorted array. Although it is simple to use, it is not appropriate for large data sets, as the time complexity of insertion sort in the average case and worst case is also order of n square, where n is the number of elements. So insertion sort is less efficient than the other sorting algorithms like heap sort, quick sort, merge sort, etc. It is less efficient, okay, and it is suitable only for smaller data set. So for example, if you take, these are the elements 4, 3, 2, 10. So we are assuming that 4 itself is a sorted. Then we are taking second element 3. So we are trying to insert in the sorted array here 3. It is inserted at position here. Okay, and then 2 is inserted here before 3. So 2, 3, 4 sorted. Then 10, 10 is again in this insertion. We have to insert at this position only. 12, 12 is also at this position. Then 1, if you take that, so 1 should be inserted before 2 here, and all these elements has to be moved here. And then 5 we have to take, so 5 position is here, so we have to insert 5 here, so that we will move 10 and 12. And then 6 is has to be inserted. So like this is what the insertion sort technique is basically. So this is the program. So we are trying to read the elements into the array, and then we are calling the insertion sort procedure, and then a lot of data movement is there in this insertion sort. Fine. So try to complete this program. And coming to this reflections part, what is the time complexity of selection sort as well as insertion sort in worst case, average case, and best case sets? So if you are not able to answer this question, please watch the video from the beginning. And the lecture outcomes are revisited here. After completion of the session, students will be able to develop the code to implement selection as well as insertion sort. So summary of this today's session is that selection sort is a sorting algorithm, so that has a quadratic running time complexity, that is big O of n square, so thereby making it inefficient to be used for large data sets. Although selection sort performs worse than insertion sort algorithm. So the selection sort technique is that first find the smallest value in the array and places it in the first position. Then find the second smallest value in the array and places in the second position. So this is repeated. This procedure is repeated until the entire array is sorted. Then coming to the insertion sort, it is a very simple sorting algorithm in which the sorted array is built one element at a time. So the main idea behind insertion sort is that it inserts each item into its proper place in the final list. So to save memory, most implementations of the insertion sort algorithm work by moving the current data element past the already sorted values and repeatedly interchanging it with the preceding value until it is in its right place. So this is a lecture level practice problem. So you can apply the both selection sort as well as insertion sort on this particular data and compare which sort technique performs better for this data item. So coming to this further readings, so textbook and reference books, these are the further readings you can refer for further enhancement of your knowledge. So thank you one and all.